an x-intercept is where y is equal to 0. A y-intercept is where x is equal to 0. So what you can do is, in your equation, you can plug in a 0 for y and solve. You can plug in a 0 for x and solve. Now it wants us to do that. Use that strategy. So let's start with the x-intercept. That means we plug in a 0 for y. And we're going to solve for x. So we have a logarithm that has a variable inside of it, so we need to switch forms to log form. So we take that same base and we raise it to the 0th power, and it's equal to 2x plus 27. And what is 3 to the 0? Just 1. 2x 27. Come back over here. So negative 26 is equal to 2x. X is equal to negative 13. So there's my x-intercept. Alright. Now let's do the y-intercept. I'll do that one in blue. Y-intercept, that would be f of 0. We're plugging in 0 for x. When it comes to the x in my equation, 0. So f of 0 is log base 3. What is 2 times 0? Is 0. Plus 27 is 27. Okay, so log base 3 of 27. You're like, I don't have a calculator, so how could I find that out? 3 to what power is 27? That's what this thing is asking this question. What power do I have to raise 3 to get 27? Hopefully you're finding out or realizing that that's just 3. 3 times 3 is 9, times 3 is 27. That's 3 3's. So the y-intercept should be 3 for this one. And I know we're not using calculators here, but let's look at this on a graph just to show you what really happens. I plugged in that equation. You go to the graph. If we went to the table, you could find the y-intercept. You see right here you've got 0, 3. So when x is 0, y is 3. And that makes sense. You can see that point right there. And then right here, this is negative 13. And we said that that was our x-intercept. Okay? So the method really works. It's not just some numbers on the page. This is what the relationship between these things looks like on a graph.